remarkable number of people sticking around. That is impressive. Thanks. Thanks very much. So I introduced Moritz very briefly before, but unfortunately you didn't get to see his lovely face. And here he is. So I'm going to hand over to Moritz to introduce himself and maybe a little bit about what he's going to chat about.
Thank you, Andy. And thanks everybody for tuning in, staying on. Good morning, good day, and good afternoon, whatever it may be in your part of the world. Yeah, my name is Moritz Lehmann. I'm Senior Oceanographer and Sales Engineer at Starboard. And for me, as a scientist, it's particularly important that the data we serve via Starboard is the best possible quality, and then it's reliable, reproducible, and fit for purpose. And I really like working with clients to solve their problems using our data.
Cool. So we're going to talk a bit about the protection and monitoring of offshore assets today, but what even is an offshore asset? It could be anything.
Yeah, well, that's right. It's not an offshore bank account in the Bahamas. So if you're here for financial advice, I have to disappoint you, and you're free to go. But I'll start a little bit earlier. So this map shows the reach of the Hanseatic League, the trade empire of Northern Europe throughout the Middle Ages, at around 1400, the Common Era. And this empire was built mainly on trade, or entirely on trade of grain, of fish, and of beer. The grain is particularly came from the Baltic ports here of Stettin and Danzig, or Stettin and Gdansk nowadays. And it arrived there through these long rivers that spanned all across Europe and Eurasia in this part down to the Ukraine. So even back then, the Ukraine was a food basket for the rest of the world and immensely important. And the material was shipped through the Baltic Sea, here arriving, for example, in Lübeck and Kiel in Germany, and then around Denmark and into the North Sea with access to Western Europe. And of course, these areas were also riddled with pirates. The ship that I'm showing up at the top of the screen is the common cogger that was used for trade as well as piracy at the time. And piracy was a huge problem until about 1400, when the mayor of Hamburg had enough and intercepted the most notorious band of pirates. They were caught, they were decapitated, and their skulls, their heads were nailed to a post outside of Hamburg to warn everybody else that they're not to mess with the assets that were stored in the warehouses in Hamburg and the ships that were providing these assets. So this allegedly put an end to piracy in the region, or so the legend goes. However, I'm showing this because trade routes that exist to this day look very similar. Here's a vessel, for example, on our starboard screen that is loading grain in Stettin. I hope I say that right. I'm more familiar with the German pronunciation of Stettin. And then taking this this grain across the Baltic to Kiel in this case. And nowadays there is a channel, or the canal, the Kiel Canal, that goes through northern Germany into the North Sea and travels there that way. Now, what happened then? We're still there's not so much piracy in these waters anymore, but other hazards. So here at this time on its journey, it actually ran into a wind turbine. So this vessel collided with the concrete foundation of a wind turbine that is part of a larger wind field in the German part of the North Sea here. Here's an example news report of that event and a picture of the bow of the ship with sustained considerable damage. And there's no picture here of the wind farm that also sustained considerable damage. And I guess we're yet to hear whether the captain of the vessel is going to be decapitated. His head will be nailed to the wind turbine to keep other people from doing the same damage. But essentially, the assets we're looking at here at sea nowadays include vast fields of wind power generators, subsea cables, monitoring buoys, and other platforms at sea. So there are a lot of things to protect out there.
My brain was going in two directions. One, are we getting into the business of nailing skulls to post here? Where are we going with this? And then two, I wonder if that boat had AIS, but I guess it probably didn't. Assuming that we're not getting into the skull nailing business, and I hope that we're not in Starboard today in the modern era. Is there anything that anyone could have done? Is there anything useful that prevents these accidents? How are our customers kind of preventing these accidents or trying to prevent these accidents with Starboard today?
Yeah. Thanks, Andy. I think we're sort of past the age of skull nailing, but what we can do with Starboard. Starboard is a real-time AIS monitoring platform. So this event could have been watched unfolding in real time on the screen. So I'm just going to zoom in. In fact, I'll drag in a geospatial file that we've created that shows the wind turbines and other fixed installations in the North Sea. So here are those wind turbine fields that we're talking about. The actual event happened right here. I'm going to turn on speed coloring for the track. It shows that this vessel here was going at full speed at its normal regular journey speed of about 9 knots. So we get 16.7 kilometers here, and that's about 9 knots. And it was pretty much veering off in a straight line heading towards this wind turbine. Looking at the situation around this vessel, looking what the other ships were doing at the time and what was around, really shows that it's a busy part of the ocean. So again, we're just looking at 2 days of AIS tracks here that's shown up in the calendar, in the time function, in the time window up here. The time set at this instant where the vessel is set by the time slider here at the bottom. And we can immediately see that there's a shipping lane that goes just due south of the wind field here, and the vessel would have just come right off and veered off, probably on autopilot. But as I say, I've tried to find some reports on the proceedings of this, and I couldn't find anything. Now, what would you do as a manager, as a person who would be monitoring such an asset? In Starboard, we actually have many clients, many customers that are using Starboard for such purposes. And one thing that we do is we draw an area around the asset that we're interested in using our area tool. And you can make this any shape you want, add some nuances here to perhaps exclude common areas of traffic. And now this might be a shape that you want to monitor very closely. You can save this area and you call it wind farm, for example. And now we can set up an alert that a vessel that enters this area will automatically trigger a real-time alert to be sent to the user of Starboard. And then proceedings and actions can be taking place that would try to prevent this event from happening. Accidents are always going to happen. This vessel traveled at 9 knots. It would have taken probably about an hour from when it first changed course here to reach this point. It's a tricky situation. There's not much time here, but making this area a little bit bigger and perhaps adding a condition on the alert that alerts for vessels traveling at a certain speed, which is something we're building right now and releasing to customers very soon, that large vessel traveling above a certain speed in this area will be generating an alert. So this is definitely sort of the area of activity, of interest that we're pursuing and that we're constantly working on improving.
Yeah, cool. And so maybe you have a bigger buffer, maybe you have a couple of hours, maybe there's an alert there, and yep, we've got the kind of ownership company information that Megan talked about before. Maybe you can contact this vessel in a timely fashion, but it's not very much time. Is there, what about in the planning phase? What about the process of establishing where this infrastructure is going to be? How are our customers working with that? Is there anything that they can do kind of more fundamentally, I guess, to lessen the likelihood without needing to resorting to skulls, just lessen the likelihood of incidents happening, of vessels coming into the area and so on and so forth?
Yeah, I'd say the first thing when you're planning an installation, an asset such as this, you take a really good look at who's in the area and who's doing what in the area. Let me just take you to another part of the world, a little bit closer to our home here, and with a lot fewer renewable sort of wind farm fields out at the moment. In fact, I believe this is just off the coast of Victoria in southern Australia here. I'll zoom out a little bit so you recognize Melbourne is right here. This is the Bass Strait between Australia mainland and Tasmania. And Australia has released some areas here for companies to conduct feasibility studies for the first offshore wind farm in Australia. And so the original area looked just like this, kind of hugging the coastline here on the continental shelf, where the waters are not too deep. So the 200-meter contour can be seen in faint blue here. There's also a lot of oil and gas development already, mainly in this part of the shelf here. But this was the area that was originally proposed. I've hid the vessels just to make sure, just to describe the area very well. I'm just going to turn on the visibility of all the vessels in the area and their tracks. So I've picked a week here, just arbitrarily picked 1 week in just the last week to show you what's happening in the area. So turning on the vessel tracks shows us immediately that there's considerable activity in this proposed wind farm area. In particular, there are a lot of vessels that appear to be just going straight through it. These are cargo vessels here, primarily, that are traversing this area. So immediately you think this is not a good idea to place a wind farm there, or there would have to be a considerable modification of the vessel corridor. So this is just showing 1 week. There's already quite a bit of activity inside the area, but let's look at that a little bit more closely. So I've got half a year of vessel tracks loaded in this tab. So looking at the same area here, the yellow Gippsland Part 1 original proposed area is underneath all those vessel tracks. I'm now hiding all those cargo vessels, or most of those cargo vessels that were going through this area. And this is just to show the vessels that not cargo vessels that are active in this area. By toggling the visibility on and off, and looking at this analysis panel here, there's 131 in these 6 months again, 131 sailing vessels, 67 pleasure craft, 19 fishing vessels in the area. Once we hide those, you can see some regular patterns here, and those are tugboats and offshore supply vessels servicing those oil and gas installations here. And so we can sort of hide these as well, and therefore can hone in and understand the activity in this area. And then what of course happened is that the planners went in, looked at the vessel tracks, looked at the areas and said, yeah, that doesn't make any sense. We're going to change this area to be not including this vessel corridor, and therefore then go ahead with a modified version of this. And as a result, the what went out as a call to feasibility studies to interested companies are the red areas that I've drawn here, which are also include a couple more offshore areas of interest. And I'm going to hide the the yellow area because it's not what we're interested in anymore right now. So while Starboard was not used to the best of our knowledge in this process, this is definitely an application that we see where our platform provides clear and definitive usage of an area for pre-planning, for early planning of activities like this. One thing that I would like to add to this plot here is is the ability to draw in more data, additional data sets. So when you're working on a project like this, you will always need specialized data. In this case, and Megan has already shown how you can drag in an extra data file. We here, for example, have created a heat map or a geojson file that shows a more complicated data set here. And this is the wind power density in this area from the wind power atlas. So immediately you can add in fairly complicated data and look at how environmental data interacts or it relates to shipping data. Yeah, so it's really important that you have comprehensive past and real-time vessel traffic data for the protection of these assets. And where we see Starboard's role is in layering this data, allowing users to add proprietary data. For example, not all vessels are on AIS. Many fishing vessels don't carry AIS, but they are being monitored using vessel monitoring system or VMS, and data based on VMS can be added by the user, specifically dragged in as a geojson, for example, and then communicated within the team. So it provides a great central operating picture for any project.
Yeah, cool. That sort of was maybe the question I was going to ask you. Everything that we're looking at here is more or less vessels saying, I'm here, and I'm here, using AIS. They're self-reporting their location. I mean, Megan touched a little bit on this before in the fisheries context, but what about vessels that are not transmitting their position? What do we do with them? And fisheries, the satellite data is challenging. Megan talked about tasking data to follow a MIMSI, and that's proven valuable in the past. In this case here, it looks like a bit of a different problem. We're closer to shore. That's often valuable. These things are not moving around. Hopefully we don't have oil rigs and wind farms kind of drifting across the ocean. What sort of persistent monitoring or what kind of work can we do here with satellite data?
Yeah, good question. One of the issues, of course, is that you also need an idea of the traffic or that you cannot see on AIS. If you know if you have additional information such as VMS or other sources, you can include them, and we're always happy to discuss with our clients on how extra data sources can be included. But satellite detections really are the only comprehensive global way to detect vessels that are not reporting. And so we work a lot with satellite companies and providers that Megan talked about. But one of the differences is that I'll be talking about here is that these are taking individual images on request, and monitoring a larger area such as this can get very expensive that way. So I'd like to talk a little bit more and define what we mean by persistent satellite monitoring. Just to take a step back, so the type of data that Megan showed were these images that were taken by high-resolution optical cameras on satellites. They have footprints of, say, 35 kilometers square here, or 5 by 5 kilometer squares or rectangles. MAXA has the capability of taking strips and several strips side by side on the same orbit. So these strips are about 15 kilometers wide, and together they can become an area that is sort of 50 by 100 kilometers long, even. It's a fairly large area. I'm showing this here over the Majuro Atoll, the Republic of Marshall Islands. The scale bar at the top is 10 kilometers here, so that gives you a little bit of a sense of scale. And while a considerable area is covered, you zoom out and you realize, yeah, it's a big ocean out there, and this is just a grain in the desert, really, or a needle in a haystack, or a ship in a big ocean. So what the resources that we also use are these satellite platforms that essentially continuously monitor the surface of the world. And I'm going to drag in another file here, another GeoJSON file, and this shows the coverage of Sentinel-2. Sentinel-2 is another satellite by the European Space Agency. This is an optical sensor, so an EO sensor. And it takes these long strips, and it covers essentially all land masses, most of the Pacific island masses, as well as much of their exclusive economic zones. So zooming back into the Marshall Islands here, here are our two footprints of the high-resolution optical, and the global coverage here of Sentinel-2 can be seen as sort of, really providing much bigger picture. Yeah, maybe I'll pause a little bit there, see if there are any particular questions that the audience might have, or any that you might have. But otherwise, I'll go on and show some more examples using this data.
Yeah, I think I'm just keeping an eye. We're sort of answering most of them in text as we go along, which I think is really good. One question I had, just explain to us again what the time frame of that coverage of the data of the Sentinel, or the blue squares essentially that you've got up is?
Yeah, that's a great question. So the Sentinel-2 coverage takes each of these images, each of these stripes, every 5 days. So it's not daily, but it's also fairly frequent. And the frequency of coverage varies between the satellite sensors as well. So Megan was also talking about Sentinel-1, the SAR satellite. That one has a return period of every 12 days. So while it's covering a lot of the same area, there are a lot fewer images that are taken over a given period of time. Also worthwhile noting that there is a commercial constellation, the Planet Scope constellation, that covers a very similar global area, such as this. Looks quite similar. It's a bit less ocean coverage, but it covers all those areas daily at a better resolution than Sentinel-2 and at a 5-meter resolution. So there are a lot of resources for persistent monitoring. By persistent monitoring, we mean you can go back any day in the past and look for an image of your area of interest. As long as it's not out too far out at sea, there's a good chance you could see something.
Yeah, cool. And I think that's probably a really important distinction between the different work. You know, Megan was talking a lot about in distant high seas pockets or sort of deliberately distant activity, if you like. And here we're looking at coastal activity, which makes these Sentinel, makes the planet data, makes it a lot more viable to have low cost kind of persistent monitoring. There's a question actually, which I'm a little bit conscious of time, and so like I know you could go on about this for about 5 hours, Moritz, but the question is, will multispectral satellite data provide more data for dark ship identification? And I guess a little bit generally about the growth in satellite data for dark ship detection.
Yeah, so there is a very good potential for detecting dark ships in the multispectral data. By multispectral data, we're referring to these optical sensors here that, in addition to maybe showing a grayscale, take red, green, and blue images and possibly some other colors depending on the satellite. So we can actually, in many cases, see the color of the vessels and learn from that color and the shape of the vessel, perhaps something about the identity or at least of the vessel type. So there is a great potential to use this data, the color information, to tell us more about the ship that we're actually looking at. And if that doesn't answer that question, I'm happy to follow up and have a more in-depth discussion around this. Yeah, one thing that I wanted to show is, and you're right, Andy, Megan showed us some great examples where you needed to look at the high seas, at distant waters with the high resolution sensor to see what's going on. Now, fixed assets are typically nearer the shore. And so there's a good chance your asset is within the territorial waters, 12 nautical miles or so offshore. In waters less than 200 meters deep. And so I'd just like to take you back to Australia, where we were looking at the wind farm. So you'll recognize this area here are the 3 red proposed feasibility study areas. And the gray strips that you see here are Sentinel-1 coverage strips. So this, we've loaded into this into Starboard here 1 month of Sentinel-1 data over this area. And all the images we have are displayed in this menu window here on the left. And the dark areas show the different strips. So as I said before, each of these strips will be revisited every 12 days. And so they will provide, and I'm going to click on one here, so the data actually fills in. They provide this grayscale image. So this is an intensity map. It's not optical. It's a reflection intensity of the radar signal. And we conduct vessel detection on this. So in an area like this, we can now look for dark vessels over a long period of time. So this data potentially goes back many years, and we can look for vessels that are not on AIS and get a picture of dark vessel activity. And dark may have some negative connotations. Vessels that are not reporting legally or illegally on AIS. So for example, we can see here a bunch of vessels with white squares. Those have been matched to a known vessel location. Orange squares in this case, because these have not been manually verified, that's why we make them orange, are detections that we made in the data which do not match up to an AIS location. And in clicking on it, you see the image chip here. And yes, if you've looked at enough of those, this looks like a vessel. Again, you click on one here, this is a high likelihood. So manually, I would verify those and say, yes, there are vessels. So going back to our list, I can download these detections here as a CSV file or a KML file, so get a nice spreadsheet back and add them all to a large inventory. I can do this over many years and see the patterns of activity, of dark activity in my area, which is then extremely valuable for a feasibility study for a large operation such as a wind farm. How are we doing for time?
I reckon we're doing pretty good. I think we're around about time. And so I reckon just a bit of a summary there. It looks like kind of the difference in the satellite data with what we're looking at nearshore. There's the opportunity for kind of persistent monitoring that you've talked about, and seeing the kind of different coverage of these different satellite sensors, the large footprints, which are picking up the kind of 20 meters and above boats, and then the smaller, high resolution footprints picking up the smaller vessels that being used kind of longitudinally to detect volume of non-reporting vessels over time. Are there any key messages I'm missing there, Moritz, when thinking about that kind of persistent monitoring?
Yeah, thanks. I think it's really important to keep the two different modes of operations in mind whenever you're using satellite data. Now, we've talked a lot about this always on or persistent global coverage of these sensors. And yes, the limitations are because, I mean, these are images that produce a lot of data every day. This data has to be downlinked and processed. So it's done often by large space agencies, for example, the Sentinel satellite fleets or the Landsat fleet by NASA and the USGS, and PlanetScope, a private commercial company. And so this is a vast resource, but it comes at the limitation that you don't get the resolution that you may need for your work. But the data is there, and there's an archive of it. Versus the on-demand imaging on the right-hand side of this slide here. Smaller footprints, higher resolution, that means you can detect vessels around about 5 meters and more, depending on the conditions. The data is more expensive, but it is a lot higher resolution. And there was a question in the chat earlier about high resolution SAR data. So there are providers, for example, Capella, IceEye, and Airbus that are, and also RadarSat, that are producing higher resolution SAR data. Again, smaller footprint, but better to discern smaller craft. This data we have not seen used very much for vessel detection. It's a lot more expensive than a similar size optical image, and that's probably why. Now, one thing I'd like to add on is sort of the in-between always on coverage and on-demand area imaging. Now, the companies like Maxar, like SkySat, and like BlackSky offer persistent monitoring of areas of interest. So you can buy imaging packages that provide you images on every opportunity there is, especially, and they look at like cloud coverage as well, and provide you as many images as you think you need for an area of interest. So you can get quasi-persistent monitoring for an area of interest, but within the limitations of these footprints and of daily overpasses. So it is a complicated and evolving market, but we're really beginning to see clarity and patterns that we can present to our clients that make this really useful for a number of different applications. But we really need to understand what it is that clients are looking at.
Amazing. Thanks very much, Moritz. I think probably that's a good time to stop it there. Those in the morning, hopefully you can get another coffee and get to their next meeting. Those of us in Aotearoa can knock off for the long day. Some of the panelists here I had meetings with 12 hours ago. And so you've been sitting at your, not panelists, rather, some of the attendees here I had meetings with. You've been sitting at your computers a long time. Thanks very much for all of the questions. This has been recorded, and so we'll share this webinar, and you'll be able to send it on to other people, and it'll be broken up into sections to be digestible. So thanks very much, particularly Moritz and Megan and everyone for coming along, and we'll see you soon, no doubt.
Thanks, Andy, and thanks everybody for attending. So long.